Okay. So, how did the homework go? Good? Not good? Horrible? Horrible? Did GitHub and stuff work better? Did you watch that video I put up? All right, that'll be very helpful, I think. It's only a 3-minute video, and it tells you exactly what you need to do to make everything work. It was 45 minutes of experimentation with Emo's Windows machine, and I think that should help quite a bit. Okay, so let's go into our code. So homework was to, when we click on something, figure out where that lives in our linked list and ultimately remove it, right? Right now we're assuming we're always removing what we click on. That's the current plan. All right, so we have to write a couple of functions here. Let me minimize this for right now. All right, so here is our label. We set a click listener on this guy. So programmatically, just getting some vocabulary stuff going on here. What is, well, we'll have to ask a question I don't know if you should be able to know the answer to. So let's just talk about it out loud. All right, so when we set the on-click listener for this label, we're teaching this label how to listen for a click. That's what listeners are, right? So what we're passing it is a new on-click listener. So this is an object. All right, we're passing it one of these. So this is a constructor. Why? Because it comes after the new keyword. And inside of this, we are inlining the on-click function that we're choosing to write. We could certainly create our own class that is an instance of on-click listener, that extends on-click listener, that has his own on-click method, and then pass this guy a new one of those. We could certainly do that if we wanted to, instead of just doing it all compressed right here. The fact that we're doing everything right in line right here is because really all we're doing is implementing this one function. And we would like this function to have access to some of these other things in the scope. Make sense? If we were to give a name to this type of thing, this would usually be called a callback function. Okay, so even though what I've highlighted here isn't just a function, it's an object that contains a function, but if we're kind of putting this in the big scheme of things, we would call this a callback function. And specifically, since it takes a function as a parameter, this guy would also be a closure. Okay, the type of animal is something called a closure. Closure is when we pass a function to another function as a parameter. Java does not support these directly, so we have to indirectly do it by wrapping it inside of an object. Other languages would allow us to send this on-click function indirectly. Not all other languages, but some other languages would allow us to pass a function in as a parameter to another function. Java requires us to wrap it inside of another object. Not that big of a deal, but the reason why I harp on this a little bit is this code right here, at a glance, can look intimidating. When there really isn't anything crazy going on there, it's just new to us. That make sense? All right, so remember this guy, this display button gets called on a per node basis. A node, and this is, I think, some of the struggles that some of you are having maybe with the homework, we want to start thinking about almost going back to CSC300 and thinking about our application here as if it's a game, as if it's a scene in a movie, maybe, where we have actors that are dancing around on the screen. So we have some node actors. How many nodes on the screen are there? Well, a number of nodes equal to the number of things in the list. right? And each one of those guys has its own capabilities. Each one of those guys is his own object. So every instance of our node knows how to display himself. Okay, so if I was a node that held the value 5, I know how to display myself. How do I do that? Well, I'm going to grab my layout because that's my mechanism to talk to the outside world. That's something called MVC. Okay, I have a layout, something that the people using the application can see, and then I have the code behind that makes that layout work. This is where I'm gluing those two together. So I'm going to go ahead and grab my layout. I'm going to inflate a view for myself, something that allows me to show myself. I'll go ahead and get the label that I'm going to put some stuff in. I'll set the text for that label, and then I'm going to teach that label what to do if it's clicked. All right, that's what this does. And that could be a little bit misleading as well, because typically we wouldn't think of labels as being clickable, but in Android, anything that is a view could be clickable. Okay, so we specifically teach this label how to listen for taps. All right, and that's what happens right here. So we're telling that label that his on-click listener is going to be this guy, and whenever there's a click, this function will get called. That's the callback thing. So whenever there's a click, this function gets called. And what do we do? Well, right now we're just spitting out the text was clicked. We're saying what the payload is. We're setting the visibility to gone, so it visually disappears, but it's not actually being removed from the list currently, right? And then we're saying what the position was. So this was the code we wrote last time that took in myself, which is what? Myself is a local variable that we created that's equal to this. Why did we need to generate that variable? Why couldn't we just say this in here? Talked about this for a little bit last time. Why did I need to create that myself variable? This one made a good quiz for today too. Okay, so it deals with variable scope. If I were to say this right here, I'm not talking about this node. I'm talking about this on-click listener. Make sense? Different scope. So this keyword always refers to this action, the most local definition of this variable. Every variable always resolves to its most local definition. In this case, this is also how a object refers to itself within itself. So we have to ask, what object are we currently sitting in? Well, a few seconds ago, we were sitting inside of a node object. But right now, we're actually sitting inside of an on-click listener object. So there's kind of two different this variables we have access to, well, that are within shouting distance right now. One of them is the local variable that we have access to, which is this, which we might think is a node, but it's actually a on-click listener. So that's not going to work because we want to pass this function, this index of function we wrote last time for our linked list, we want to pass him a pointer to a node. So that's why we went ahead and preserved a variable that we had access to called myself and set it equal to this so that when we lost track of this in here, we still had access to myself. That make sense? All right. So effectively, we are printing out the position in our list where myself lives. And this should work. I think we tested this last time. And we're visually seeing our view go away, but it's not actually being removed from the list. The homework was to get it out of the list, which effectively means we have to do a remove AddIndex from our in our list, where we can pass it in an index. We could also just pass it in the self, but let's keep it compartmentalized. So we already have the ability to say, where do I live in the list? And we get back a position. Now we can then tell the list to go ahead and remove me. Make sense? And what does removing me from the list mean? It means go through the list, find out where I am, and we already know that. Okay, we already have the index, and disconnect the crap before me, disconnect the crap after me and connect those guys together, leaving me floating out there in space. And then allow me to die a peaceful death as the garbage collection comes through and gets me. Make sense? Because at that point in time, my pointer count is 0. That means nothing actually points to me. Nobody has access to me. Therefore, garbage collection is going to clean me up. It's going to wipe me off the street. Okay, so that's what we need to do inside of our remove AddIndex. All right, so right now we should have this dude cooking in the emulator. All right, so if we add some stuff to the front, add end, whatever. If I click on 7, this should be 0, 1, 2. The 7 should disappear. It should notify us that I'm going to be removing 7 from position 2. And we should see that out here. Text was clicked 7. It was found at position 2 from the code we wrote last time. Now our final step will be to actually remove it from the linked list. Because as it stands right now, we visually don't see it anymore. It's physically not taking up space. But as soon as I add something back to our list, it's back. Because it never actually left the linked list. So when I tell that linked list to display itself again, I'm going to put everything right back out there. And since it built a brand new node, and well, since it asks the node to display itself, which builds a brand new layout and a brand new label, it's no longer listed as visibility gone. It's now visibility, you see me. Okay, visibility, visible, I'm guessing. Okay, so we need to actually, in our linked list, write a function to remove @index. So public node remove @index, and this guy will take in a index or an int index. All right, so now we can make a couple of assumptions here. We could assume that the index that's passed to us is always a correct index. Now we are keeping track of count, so that should work. So we can do a couple things here. We'll do a little error checking. So for starters, we can ask the question if index is less than 0 or index is greater than or equal to this dot count. Because we did it as a 0 base, we treat our linked list like arrays. So if we have 5 elements in it, the last legal guy to remove would be 4. Correct? So that's why we say if it's greater than or equal to the count. If we're trying to remove, if we have 5 things, the last legal position is 4, and we try to remove 5, we shouldn't be able to do that. All right, so we could throw an exception here if we want, but so I don't have to throw exception stuff in, we're going to do system.err.println array index, or linked list index out of bounds, and we'll print out index there. All right, have we seen system.err before? It's exactly like system.out. Every operating system has built into it 3 streams. We have one input stream called system.in, and we have 2 output streams. One's called system.out, and one's called system.error. So system.out and system.error are 2 different ways of printing out to the screen, but they are in separate channels. And to kind of show you an example of that, let's see, where am I right here? Let me do something like blah.blah. Okay, so we're seeing no such file directory. This is going to be an error. Okay, so if cat just prints something out to the screen. Cat needs it out to the screen. If I redirect that to error.txt, like this, I'm going to still see the error on the screen. And if I look at error.txt, there's nothing in there. But if I redirect the second output stream, which is system.error, Now we see nothing to the screen. Because instead of letting system.error come to the screen, I redirected it to a file. Now if I look in that file, I see our error message. Okay, so those two output streams, this is the contents of that file right here. Those two output streams allow us, if we choose, to separate the difference between normal output and error output. Maybe error output goes to a log file, something like that. So think about this at the operating system level. Every operating system is going to have this built into it. That's kind of common operating system lingo. All right, so having said that, Java supports this and allows us to choose if we're going to write out system error or system out. Under normal circumstances, they'll both just spit out to the screen. I think Eclipse treats anything on system.error as something it should show up in red. So I think it color codes it red for us, kind of showing error is bad type stuff. All right, so we're doing this instead of an exception just to allow us to focus on the linked list aspect of this rather than the exception handling stuff. We did some exceptions last semester, right? Didn't we do throw and stuff like that? Yep. So well, at some point we'll bring them back, but for right now we're going to make some assumptions that if things go wrong, it was user error and we'll just not screw up the next time we run it. All right, so we can focus on the rest of this. So this first if statement says, is the index out of bounds? If it's not, if we're still kicking right here, we can say if index is equal to 0, return self dot, oh, different language. I was programming in Swift this morning. Remove front. So why reinvent the wheel, right? So if we are, we have not written a remove at index yet, have we? This is our first time? Good. All right. So if index is 0, well, if we're here, we know that it's a legal index at least. If index was 0, we'll go ahead and just leverage our remove front that we already wrote. We know it works. Else if index is equal to this dot count minus 1, then we'll do return this dot remove end. All right, so everything up here is all about using what we've already built. We've either spit out an error, and what I'll do here just for, we're going to return null. In the event that we spit out an error, we're going to say, here's your non-node, but a returned value nonetheless. Good luck with that null value. But we have advertised that we will be returning a value, so we'll fulfill that obligation right here by actually returning a value. So this is, if it's bad, do that. If they asked for us to remove bucket 0, let's just use the function we already wrote that removes bucket 0. If they asked us to remove the last legal bucket, we'll just use the function we already wrote that removes the last legal bucket. Otherwise, we need to go ahead and remove the guy at a specific index. So let's go to our drawing board. Okay, so this is bucket 0, this is bucket 1, this is bucket 2. Right? And actually what I'm going to do here, just so we can handle this, because we will have a special case in here. We're going to do that. So let's look at what happens if we want to remove bucket 2. 0, 1, 2. Okay? So ultimately what we need to do, if we kind of think ahead, in order to remove this guy, I need to ultimately make this guy point here and this guy point to null. And then we'll let garbage collection pick them up. That make sense? That's what we need to be able to do. Now that might be easier said than done. In order to do that, we're going to have to get access to this guy. We're going to have to get access to this guy. We need to know about the two guys that we're going to hook up. Okay, we already know the position of this guy. What's probably going to be easiest for us, even though we don't actually need 3 variables, is I think it will be helpful for us to have three variables. So we have one variable that points here, another variable that points here, and another variable that points here. So we have distinct variables that point to each of our little players that are going to be involved in this switcheroo. Make sense? All right. So what we're going to do is we're going to go ahead and we're going to walk our list all the way up to the dude right before the position we're removing. Okay? So that means if we're going to position 2, I need to take one step. I need to go from bucket 0 to bucket 1. Okay? For int I is equal to 0, I is less than index minus 1, I plus plus, so we know exactly how many times we need to traverse, right? Now we're going to create three variables. We're going to create node, this is the node before, node, and let's just start these guys off as equal to head. Node to remove, and we can actually start this guy off equal to null. And then node after, he'll be null as well. All right, so we have three variables for our three players that are going to be involved here. This guy right here is going to position our node before. Okay, so position node before to the node before the node we want to remove. So we're going to say node before is equal to node before dot get next node. So now node before is positioned where he should be. All right, if I was trying to remove bucket 2 here, node before just went from 0 to 1. That makes sense? Went through one time. And we did that traversal. Okay, so node before is currently pointing right there after that for loop. Now, we want to set node to return equal to that guy, which is node before dot get next node. Oh, we called it node to remove, not node to return. All right, so we're going to set node to remove equal to node before dot get next node. And then we're going to set node after equal to node to remove dot get next node. All right, so visually we understand what we're accomplishing there. Three variables, 3 pointers pointing to the 3 dudes involved in our surgery. All right, where we're going to remove this tumor right here. All right, so this guy gets us to the node before. Then we use him to set the node to remove. And then we use node to remove to set the node after. All right, now we need to actually do the connection stuff. I know that node before is going to have to ultimately point at node after. So we're going to set node before's next node equal to node after. Node before dot set next node equal to node after. That does that part. So that just made that connection here, which disconnected us from this, but we still have access to it through this variable. Okay? Now, we're going to set node to remove equal to null to fully disconnect him. Dot set next node equal to null. So that's this. And right now, node to remove is nothingness, correct? And our list is now the new version of itself. All right, so does that make sense? How we can return from bucket 2? Let's look at, see if bucket 1 is any different. So if I want to remove this guy, index will come in as a 1. That's not the beginning of the list, that's not the end of the list, so I'm going to have to do this extra work. So I need to get node before to get right here. So I'm going to go for I equals 0, I is less than what? 1. 1 minus 1. Does our for loop already handle that? Does. So if we want to remove bucket 1, we're going to have this loop go to index minus 1, so to 0. So how many times will the body of this loop execute? 0 times. Remember, for loops are pre-check loops. There's no guarantee the body of the loop ever executes. So we'll start I off at 0. Then we're going to ask the question, is 0 less than 0? It's not. So we skip past the for loop, and node before is sitting right where we started it, at head. And is that where we want it to be anyways? Is this the node before the node we want to remove? Sure. Then we'll set node to remove equal to node before's dot next node. And we'll set node after equal to node to remove dot get next node. And then we'll do our same little logic. All right, so do we have a solution here? Something bad, don't do anything, scream about it. If you ask to remove the first thing, let's just remove the first thing, calling our remove front. If you want to remove the last thing, let's just call our remove last thing, calling our remove end. Otherwise, we'll go and do our little magic trick by figuring out what's the node right before the one we want to remove, what's the node that's actually the one we want to remove, and what's the node following the one we want to remove, and then we'll do our little connections. All right, so now we should be able to ultimately return node to remove in that else, because we have fully disconnected it, correct? It's just sitting there, nobody's pointing at it. We're going to return it in case whoever removed it wants it. Okay, if they don't want to use it, great, but we'll give it to them anyways, because that's going to be garbage collected shortly if he doesn't use it, if he doesn't store it somewhere. Okay. So let's go back into our code here. We'll go into our node.java. So right here, we're printing out the value we've clicked. We're visually making it disappear for right now. All right, because as of right now, that list is different. Okay, for right now the list should visually look different, but we haven't actually removed it. Then we're going to go ahead and remove it from our linked list. So what do we call this? List core .ll.remove @index. Okay, and the index we want is the index of ourself. So we'll immediately make it disappear visually. We'll go ahead and actually remove it. And then just for good measure, which means that we really didn't have to make it disappear if we didn't want to, we can say listcore.ll.display. we'll go ahead and ask our linked list to redisplay itself, which should now display a list with one less thing in it. Okay, and if you want to prove that that's correct, we can comment that out, and we'll do the remove, and then we'll do the display. Now, not only should it visually show us a list with something removed, but that element should have actually been removed. So now adding future things should not bring back the dead. All right, so I'll click on that. He disappeared. If I do 14 add front, notice he's not back. 14 add end. If I click on the 14, he's gone. If I add 7 to the front, 7's back, 14's not. If I click on this guy, it's going to call remove an index, but it's going to actually end up calling remove end, right? Because this guy's at the last position, so that removed him. If I add a 7 at the end, so we seem to be able to remove individual guys. There's the 6, he's gone. We can add a 4 to the front, he's back, so on and so forth. Make sense? All right, so was that the solution to homework? All right, so something along those lines. All right, so we had to write this function right here, remove AddIndex, to actually get it out of the list, and we already had the functions to make the list look visually update if we were to tell the list to display itself. All right, so now what we want to do is we want to look at what if we have some options. Right now we are saying that we want to, when I click this, we're making the assumption that we are going to delete that value. Okay, but as she pointed out last time, maybe we want to add something before, add something after, right? Okay, so just so we have some decent starter code, Android pop-up menu. Might be a context menu we actually want. No, this kind of looks like maybe what we want. Little thing, we click on it, it asks us delete, add before, add after, something like that. And then beyond that, it might give us a thing for another number, right? Well, actually, maybe we don't need that. Maybe we can use our text box we already have at top to add something. So let's get this pop-up showing up. So when we click on something, here's our pop-up menu. And we're going to want this guy to, this is going to happen around this label. Looks like they have a, the pop-up button is going to be a pop-up associated with that. So we're going to have it associated with our label. So here we'll start with this guy. Let's paste it into our code. So for right now, we go back to our node. We are, will ultimately end up still removing stuff sometimes. All right, but for right now, let's just comment these two lines out and let's focus on our pop-up. So we'll go ahead and put the pop-up menu in, and we're going to, with option enter, Androids. All right, and the context for this guy is going to be myself. So we're going to have the pop-up show for this node. Okay. Actually, we probably have the context for it show up for we might want to give it a layout, actually. Let's see what happens with that context. But this is going to be V. we want to have that pop up on V. What's this guy screaming about? Oh yeah, it doesn't like the myself. So first value there, he wants to have an activity. So we need to have our main activity. Do we get a main activity dot this out of this? Maybe we do. Well, it doesn't look like it. So let's do this. We'll add in our list core the ability for us to gain our main activity, because anything we're showing on the screen has to have a context in which it's showing. And context can be an intimidating word, but what it means is where we currently are. So if I want to have a poster up in this room, my context is this room. This is where I want that poster to be shown. So our node is an object. It's the activity that the node is presenting itself within. So it's that activity, that main activity we have, that's the guy that we ultimately want to show our pop-up. All right, so we're going to need to have access to him. And since we're inside this node class right now, we don't have access to the things from the main activity class, we're going to go ahead and store it inside of list core, which allows us to share things throughout the application. So we'll put in here public static, and this guy is an activity something. It's like a special kind of app compat activity. It's one of those dudes. All right, and you probably could have just said activity there as well, but and then we're going to call this guy main activity. Okay, and we're going to go ahead and set his value in main activities on create. So when our main activity first comes into existence here, let list core know about me. So we'll say list core dot ll, actually not dot ll, dot main activity is equal to this. All right, so we threw a pointer to ourselves up to list core in a variable called main activity, so that over here in node, when I need to get a pointer to my main activity for my context, I can say list core dot main activity for showing that pop-up. Make sense? All right, so this is all about context and all about scope, variable scope. If we're sitting inside of the node object, we don't have access to our main activity. But not all is not lost, because we've now mastered the idea of the singleton. All right, singleton says, if you need something that you don't have access to, go ahead and throw it in there. Now you have access to it. All right, that's the singleton shortcut, if you will. So this will be our pop-up menu. So we're going to go ahead and have to get a menu inflator from that pop-up. Let's see, r.menu, pop-up get menu. This is probably we'll have to see if we have to build our own menu. We might have to build our own XML. I don't know if that's a built-in thing. Yeah, it's not a built-in thing. So we're going to have to create our own XML for our menu. That's probably what they did up here. Yeah, here's their pop-up menu XML. So here we'll just steal their XML code from right there. We'll go back in here. We'll go to our project. We're going to go to our layout. Let's see. So this is creating a folder called menu. I don't think we have to have it in there. I'm just going to go into layout. I'm going to do new layout resource file. And this guy is going to be there a way for me to choose a menu as my starting point? Call it pop-up menu. Looks like I could have renamed it. I'm just going to put it in layout. It's not going to hurt anything. All right, so that gives me this new guy called Pop-Up Menu. And I'm going to gut everything that's in here and paste in this guy. It's not have required attributes, Android class, layout, height. It doesn't like something there. Okay, so let's go back here. Let's go into our design. Do we have a menu layout in here? Maybe in advanced at the bottom. Maybe we don't have to treat it special. Let's just try something here. Let's go into our text. We'll go in here. I'm going to paste this. All right, it looks like we can put a menu inside of a linear layout. Oh. So let's do that. Linear layout's already vertical. See what that guy looks like. Java can cause rendering features, blah blah blah. Okay. All right, it wants us to do some of this stuff. Oh, you'll even add it for us. Beautiful. Okay. I don't think we want to mess with that. We got to be building our menu wrong. I bet that we can just do this. Let's forget about that side of it. And we're just going to throw three things out here. One, two, three. So we'll just do that. And this is inside of a file called r.layout.popupMenu. And hopefully you can just lay it out. I don't know why it wouldn't be able to. So the pop-up menu inflator is going to be r.layout.popupMenu. Expected source of type menu. Okay, well, he didn't like that. So that must mean there's a way to create an actual menu. Okay, that's fine. Then how do I make this guy a menu? Android menu layout. Creating a pop-up menu. Define your menu in XML. Okay, well, it wants it in a folder called menu, and then it looks like the thing we had before was fine, but how do we actually ask Android to create that for us? Do we magically create a new folder in here called menu? Oh, it's not in layout. It would be in here. New directory, menu. Then we can create a new, there we go, new menu resource file. Okay. Well, that's not very user-friendly at all, is it? So basically it's create the fictitious folder called menu, and Android Studio will do the rest. So we just created a folder called menu inside of resources, and now all of a sudden Android Studio knows about menu resource files. And we'll call this Popup Menu. Okay. And then we'll copy those items that we had here before. Just for our starting point. We'll save that. Now we should go back to Node and be able to tell this guy that we have something called r.menu.popupMenu. And now he's substantially happier. Oh, back here. Alright, so we have that. So there's our menu inflator. And here's our menu listener dealie. So we'll go ahead and do that and do our pop-up show. And this is all inside of our on-click. So this should handle the rest of it. Well, actually, for right now, we don't even need this. We should be able to show the menu. And then we'll build it programmatically. All right, so now when we click on one of those dudes, it's just going to show the menu. The menu won't work, but it should show it. So it's not clickable, but let's see what the menu does for us. All right, so there's our menu, 1, 2, 3, and eventually I'll be able to click on one of those, but I don't have a click listener right now. So let's go ahead and add a click listener. So it didn't like the code I just pasted in, so let's try to write it ourselves. So we're going to say popup.add set on menu item click listener. This is going to be a new menu, new on menu click item click listener. Like that. Yeah, a lot of times Android Studio will do the work for you of making sure the code gets written right. So then for right now, let's just print out system.print system.out.println clicked on item dot get title. That'll probably tell us what we clicked. Oh, and this guy has to return a Boolean. Return true. Just because the on menu item clicked returns a Boolean. So now let's see if we can have this guy responding to us actually clicking an item. Click on 1, so it says clicked on item 1, clicked on 2, clicked on item 2, clicked on 3, clicked on item 3. Fair enough. All right. So now we can say, I was wondering if there was a item index or something instead of using the string, but looks like we have to use the string. So now we can say, well, let's first change our items to no longer say 1, 2, and that stuff. It should now say delete. Let's do it all caps. Add above. Add below. All right. So then in code here, we can ask if item.getTitle dot equals delete, then do the delete stuff. And for right now, we won't do anything for the other two. So if I click on the 7, and then I say delete, it's gone. If I add a 12 to the front, we see it's still gone. So now our drop down is letting us do the exact same thing we did before, but now we have a couple of additional options. Okay, so now if I click on this 6, and I decide I want to add something above, maybe the idea is that whatever I have typed up here, so maybe I hit an 8 there, and I do this add above, the 8 should go above that, right? All right, so that means that if I want to put the 8 above the 6 is currently at index 1. That means I want the 8 to become the new index 1, correct? Shoving the 1 or the 6 down to index 2. If I say add below, the 6 is currently at index 1. I want to actually make it at index 2. Make sense? That's where I want to add it. So we're going to have to write a function called AddAtIndex. Public void AddAtIndex int index, and this guy's going to take a payload as well. Is that what we've called it in all the other ones, or we called it a value? Payload, add front string value. So we're going to add string value, add index, and this guy should add a new node to the list with payload equal to value at the specified index, assuming that index is a legal position in the list. That make sense? All right, so that is going to actually be your homework assignment. But I'm going to show you some new stuff from here. So what I'm going to do is I'm going to go ahead and I'm going to push this to GitHub. So this is going to be homework 7. Okay. And then I'll show you what I did on GitHub to make that assignment work. And then I'll show you the new thing. So I'm going to show you how to go to a new activity now. So we're going to start moving over to stacks and queues and things like that. All right, so we're going to go to VCS. I'm going to go to Git. I'm going to go to branches. And we're going to create a new branch. And this one's homework 7. Okay. Then I'm going to go to Git, do commit. And I'm going to say this is a new branch for homework 7. And it's showing our, actually it should show all the changes. Let me back up for a second here. Tools. Well, let me just do commit changes here, not under Git. Commit changes. Okay, that selected them all. New branch for homework 7. I'll do commit, commit and push. And then I'll go ahead and hit commit. And finally push. So now they're up there. And now let me go to GitHub. All right, so we see that there's a new branch called homework 7. So I'm going to go to settings here. I'm going to go to branches. And I'm going to choose the new default branch. And I'm going to choose it to be homework 7, the one I just uploaded. So now when you do a pull, it'll pull homework 7. You don't have to like specify homework 7. That's the new default pull, is the homework 7 branch. Make sense? All right, so with that in mind, if you watch the 3-minute video, your homework should be easy to start. is the punchline. It should also be easy to submit. The tough part is going to be the sandwich in the middle of actually doing it. All right, so let's look at some new stuff now. So I'm going to close that pop-up thing there. We're going to go back to our main activity. Where's our activity main? This guy. All right, so right now, remind me later. All right, so right now we have a single activity here. Well, we might want to have a second activity in our application, right? Screen number 2, for example. So we need to have a way of getting to screen number 2. So I'm going to start off by, let's build the code for our second screen. So I'm going to right click, we're going to do a new activity, and we're going to do this. I like to make it an empty activity. If you think back to when we first created our code, the Android Studio gives us a way to like choose our starting point, and one of them is called blank activity. Blank activity still puts a couple of things in there. I don't like those. I always start with an empty activity. So we're going to start with an empty activity, and we're going to call this guy screen 2. And notice it's already giving me a layout name. Actually, we're going to call this guy stack screen, stack activity. It's called stack activity. All right, because we're going to be starting to move into a stack. We'll go ahead and let it generate a layout file for us. It's going to name it activity stack. We don't want it to be our launcher activity unless we want it to be the new launcher activity, which means it's the one that launches when our app starts. So we'll go ahead and hit finish. So now we have our basic stack activity. And now we can go ahead and modify this. And we're just going to put a text box out here. And we're just going to say stack activity here, just so it shows up on the screen. Okay. Now we want to create a scenario where we can actually get to this activity. All right. So we're going to go back to our activity main. And what we want to do is we want to provide a button. Let's see, where can we do this? We can do it up here probably, because we don't need all that space for our number entry, right? So we're going to go ahead and we're going to throw a button up there. I'm just going to do a normal button actually. All right, so we're going to have it go to our stack screen there. Okay. And if we want, we can go ahead and scoot this over a little bit more and have it fill out the, let's just say that's good. All right, so we're going to make the on click for stack not call that generic function we wrote for all of our other buttons that figure out what we want to do. We're going to have this guy be his own method for this. So we're going to go to on click for that stack button. And we're going to call this stack button clicked. Okay. And now we're going to go into our main activity. And we're going to write the function for handling that. Public void stack button clicked view sender. All right, and just as a quick test, we'll do a system.out.println stack button clicked, and we'll run this, just proving that we can indeed click the stack button and it responds through this function, not one of our other functions, or not through any function at all. So, good thing to test this kind of stuff before we start writing a whole bunch of extra code in there. Stack button click down there. Everybody's happy. Okay. Now, when we want to go to another screen in our application, we do this through an intent. We intend to go to another screen. And part of this has to do with how communication happens between activities in Android. For an iOS application, all of the screens are housed within a single pod. Okay, they're all called view controllers, and they're housed within something called the NS bundle. In Android, every screen in our application is kind of like its own application. So we need to create, we're almost like launching a rocket to take us to a new planet. And that new planet is our second screen. And anything that we need to take with us over to that second screen, we need to throw on there with baggage, or we can use our magical singleton, which just magically works across an application scope. So we're going to look at an intent here. So I'm going to say intent I is equal to new intent, and we'll go ahead and bring that guy in. I think I just have to give it the context. Let's find out if that's the case. I think I'm going to say this, comma, stack activity dot class. All right, I think that'll do it. So this is my context. That is, I'm going to be launching this rocket from within main activity. I'm currently sitting in main activity, so the context I'm going to be starting this new activity through is this guy. What am I starting? I'm going to start my stack activity. Okay, and stack activity.class kind of says, that's the template. That's the dude over there. I want you to magically inflate him or do whatever magic you do to build me an activity and then show him on the screen. Okay, this is an intent. An intent doesn't happen until we tell it to happen. So now we're going to use this dot start activity, and we'll give it our intent. Okay, so this will go ahead and build up that second screen and then show it on the screen. Go ahead and run this. All right, so all the rest of the stuff should work like it worked before. And now I'll click stack, and it takes us to our stack activity. Now, something that's interesting and different about an Android device versus an iOS device, I had a reminder, how many of you are Android users in here? Okay, a couple people. A substantial difference between the two interfaces is every single Android device is assumed to have a built-in back button. It's part of the Android interface, right? Okay, so you know whatever screen you're currently on, if you want to get to the previous screen, whatever that was, whether it was in the same app, whether it was one of your music apps, whatever, you know to get to the previous screen, you hit back button, right? Okay, so this takes us back to the previous screen. If I want to go back in here, I can hit that guy again. Now, let's look at something here. So what we're going to do is, in our second activity, let's actually give ourselves access to our little label here. So we're going to click on this guy. Well, we'll just call it stack title. Let's call it that. So we're going to, and that guy's a text view. So we're going to go ahead and give ourselves programmatic access to that. We're going to change its value. Let's see. How do I want to? Need to do it in a very specific way. Okay, I got it. So let's call it stack title. Let's go into our stack activity. I'm going to create a variable up here called int count, and we're going to start this guy off at 0. Then I'm going to go ahead and say text view title is equal to the text view version of this dot find view by ID r dot ID dot what is it, title, stack title. Now I'm going to ask the question, if, well, before I do the if, let's just do this. We're going to say title dot set text equal to count is equal to count, and then we'll say count plus plus. And I like doing this dot in front of that. Okay, so even though we've written stack view or whatever we wrote on it, the very first time this launches, it should say count is equal to 0. Okay, but then count gets 1 larger than it used to be. Okay, now I'm going to create a on activity need to, I think it's on restore. Is it just on restore? Here. Activity lifecycle. All right, we have something called an activity lifecycle that tells us when an activity is stopping and starting and all that stuff. So come in here. So it must just be on resume. Yeah, on resume. Oh, there it is. That's, so is it a fragment activity? Okay, whatever. I'm going to take those exact same lines here. I'm going to put it on resume. And I guess we need to get our title again too. We probably would just put that as a global variable, but just to make this work real quick. When this activity is first created, it should say count is equal to 0. Then count should go to 1. Then I'm going to hit back. I'm going to go back into the activity. What we want to know is, does it create it again, giving me a count of 0? Or is it resuming the existing activity, showing me a count of 1? Make sense? So let's run this real quick, and then we'll stop there. I'll put your homework assignment up, but I won't push this code. You'll have the starting point from what I pushed a few minutes ago. But this is going to give us some information on how activities start and resume when we go back and that kind of stuff. So I'll go ahead and hit stack. There's our count is equal to 1. I hit back, go back in. Still 1 actually, because on resume always got called. But punchline there was, when I hit back and then I started it again, I got a fresh activity, right? So we want to think about what happens if I actually want to have an activity that maintains its state for when I return to it. That might be something that's helpful for us. All right, I'll put the homework assignment up. I will see everybody on Tuesday.